Okay, here we go. Silence of the lambs. All right. Now, so today we're going to bust into. Are you texting or is that your calculator? That's your calculator. You know, what'd be smart. I think we talked about this last year. Making a phone that looks like a calculator. So then we could, we could cheat the teachers all the time. Sorry. Okay. So this is an old. We stole this off the internet. Completely illegal. All right. I went searching last year for encoding, decoding ideas, and found this. This is from a. Someone posted this online from another book. So I'm fine. I'll, say this is from an Algebra 2 book. But I guess I could zoom in on this and actually, let's go back. You should put these two words together because students, I remember last year, had these mixed up. So this is not your packet. I see people looking through there. The packet is actually your homework, but don't freak out yet. As a matter of fact, I was overzealous maybe. We're not even going to do the front page. We can hit that later. So don't worry about that. But get your own notes to take a couple things down if you're a good note taker. And then the two words for the day are encode and decode. And I remember students, or encrypt and decrypt, it's the same thing. Fumble, or like just throw it on the ground, I don't know. And what we got to know what those meanings are. So encode means to take a sensical statement, something that I understand, I can read, and scramble it and turn it into, a secret message. So encode means take it from knowing what it is and turning it into a secret. And then to decode means to unscramble the message. That means bring it back from nonsensical to sensical, if I'm using too big of a word. But remember in the movie, that's what they were doing when they were in school. They were, doing some little encryptions and sending an encrypted note. And then all you had to know was what was the key to decrypt it or decode it. Blah, 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 blah. So encode is to take a sensical statement and scramble. Decode is to unscramble. So cryptogram, they even go over the Greek translation. The Greek word kryptos means hidden. And the Greek word gramma, which means letter. All right, so that's where this cryptogram comes from. You don't have to write this down because I think, first of all, on your test, you'll have this code up there because it's kind of a pain. I mean, I'm sure A is 1, right? That's simple, right? Z is 26. But what's P? And then you'd be in a position, all right, A is 1, B is, then you have to keep counting. And then that would take forever. So this will be provided on your test. You'll have one page of encrypting and decrypting with the alphabet code up at the top. All right? So you don't have to worry about that. Now, do worry about this. It depends. For this particular Algebra 2 book, a space is 0. I've seen other ones use a space as 27 because it's after 26, which would have to be Z. There's 26 letters. And why you would need a space is to separate words. You'd want... my name is Dan. All right, well, I need spaces between all those letters. But there's another reason. In order to use matrices to multiply, you need the number of columns of the first to match the rows of the second. So you might have to end a message with blanks just so that it fits in matrix multiplication and I can actually do it. So I can actually multiply, have proper dimensions and all that other stuff. So spaces have two reasons of being. They separate words, but they also make the matrix multiplication happen if you need to at the end. Okay? All right. So, very first thing we're going to do, and you got to listen to what I say here because it's your job. Your job, and actually before you encode or decode is, what's the schematic? How does it work? And you have two possible ways of doing this. And I'm going to verbalize it, and then we're going to tell you how this Algebra 2 book did it. First of all, we're going to have to take get help. And this is what they just said. Let's take get help and actually encode it. So this is sensical. All right. What we're going to do is encode it so it's a secret message. So number one is we have to go to our coding of letters and actually code this message with the letters that correspond to it. So G is 7. I didn't get to what I was going to say there yet. Just give me a second. G is 7. E is 5. And you might want to use commas because what if it was a 2 then a 5? You might accidentally think it's 25, which is a letter. So you might want to use commas for this. T, I don't think I really need this on line 20. So I'm going to pause the video as I get these letters. Okay, so like I said, there's two possibilities. Here's one possibility, and I've told you this before. Are you okay back there? You need a pillow? Messing up against that board? Okay. One is I can encode by putting the matrix on the left or the right. Matrix multiplication is not commutative. If I do one or the other, I get a completely different thing, and we need to understand that at this point. So your job in reading the directions, especially on the test Friday, where am I putting the encoding and decoding matrix? Is it on the left or is it on the right of the thing I'm trying to encode or decode? That's number one. Number two, I have an option of how putting these letters in order. I can put them in order of rows, so I could do 7, then 5, and then I'd have to see how my dimensions have to line up. Or I could do 7, 5, 20, 0. I could go rows or columns. It depends how you encode it, how it has to be decoded. So there's your two possibilities. Where is the encoding matrix? How are you putting the letters in the message matrix, we'll call it. This particular coding or encoding does it the following way. They multiply on the right. So they take this encoding matrix and multiply on the right through a management decision that they made. The other management decision they made is they decided to put the letters in order by the rows. So they do 7, then 5 right next to it to the right. Don't be falling asleep there. This is critical. Okay, so let's talk about that. And by talking, I say I'm going to talk and you're going to listen. All right, so here's the encoding matrix. 2, -1, 3, -2. And it's got to be on the right of my message matrix, which I kind of put this in a weird spot. So let me be a cowboy. Yeehaw. Cowboy, baby. All right. And now, what's the what's this? What is this? What's the dimensions of this? What are the dimensions of this encoding matrix that I'm forced because they told me to, because that's the rules. Without rules, there's anarchy. All right? It's a 2 by 2. So by golly, what is this, 1950? What do the dimensions of the message matrix, we'll call it, at least have to be? What do one of these two things have to be? 2 and where? 2 is a where? To the where? Right or left? So this has got to be a blank by 2, right? That's the only way that this could actually be multiplied out. This is what you got to figure out. If I'm forced to put the encoding matrix on the right, then I'm forced to have a blank by 2 on the left because those dimensions in the middle have to line up or else matrix multiplication doesn't work. Whew, that was a mouthful. Okay? So now, how do I do this? Well, here's the next thing. And then I'm just going to start this off, and then we're going to actually, don't write any of this down because I ran out of room. Okay, what was the next thing we have to know? Well, okay, and I think this is how it works on your, look at that, 7. Whew, so shaky. Old age kicking in. 7 and then 5. See, that's how this one works. They go by rows by putting this in order for the letters. 7, 5, then 20, then 0, and then dot, 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 dot. And then we notice that how many letters do we have? 2, 4, 6, 8. Who do we appreciate? Not Mr. S, not Mr. S. He's a jerk. Check Twitter. All right. So now, watch how I'm going to change this. I don't like how this Algebra 2 book did this. What you should do is make this one big fat 8 by 2 matrix and multiply it by one of those 2 by 2 matrices because it works. So that's what we do. We got that get help. We changed it into 7, 5, 20, 0, 8, 5, 12, 16. And we're going to make it a secret message by encoding it, by multiplying it by this 2 by 2, 2, 3, -1, -2. Is everyone okay there? So that's what I think. That's how you're encrypting and decrypting. Actually, you're decrypting or decoding tonight. How it works on your homework thing. All right. So then here's matrix multiplication again. If you don't know matrix multiplication, you belong out in the weeds right now. Because what do you take first? You take the. Sorry, you were absent a few days. Do you know how to multiply though? You take the rows of the first and multiply them by the columns of the second, and that is why those twos must line up. That means you're going to have two numbers times two numbers. So you have dimensional match up here. So 7 times 2, 14, right? Plus 5 times -1, -5. And then 7 times 3 is 21. 5 times -2 is -10. This is how I think you should construct your multiplying. And if you need a calculator to do some of the multiplications, go ahead and do it, and then write it down. Then taking this row, and if this is boring, that's fine. But I still think some people are sitting here who don't know how to multiply, which is not good. 20 times 2 is 40. So 20 times 2, 0 times -1. Then I take 20, 0, and I multiply it by the second column. 20 times 3 is 60. Speed it up here. And then 0 times 0. Good. And then I take the next row and multiply it by each column. 8 times 2 is 16. Getting something here? 5 times -1, -5. You okay? You didn't answer. Yeah. Okay. 8 times 3 is 24. 5 times -2 is -10. So, what's the matter? Why is it minus then? It's not minus. It's 8 times 3 is 24 plus 5 times -2. I just decided to make it minus. And then 12 times 2 is 24. 16 times -1 is -16. 12 to 36. Right? 12 times 3, 36. And then 16 to -32. All right, so now what we could do is go ahead and finish this, but what they want the encoded message. Now remember for the Enigma machine, it always ended up being a letter, but the letters were nonsensical until you got the correct coding, till they cracked the code. Then the letters turned into sensical letters where the message could be understood. All right, so 14 minus 5 is 9. That could be converted to a letter, right? Someone look up 9. What's 9? 11. That's I. And then what's 11? K. And then is the next one 40. Is that even a letter? No. And I've seen some stuff. I think it was one of the ciphers that I looked up that you could mod 2640. 40 could turn into mod 26 and figure out what kind of letter it is. You know what I mean? Get rid of 26 of them, and then what does it actually end up being? That's another complicated. We're not going to do that, though. You just shut down. Okay, so my point is this is definitely nonsensical. This is something that does not even translate to letters in some cases. 14, what's this, 8? And what is this, 4? Okay, so there's your encrypted or encoded nonsensical message. It's a secret message. And the only way you could decode it is if, to be honest, you were given the encoded matrix. And we're going to tell you what we do about that in a moment. Okay? All right, so there's encoding. Hey, by the way, I thought this was interesting. We saw a movie about Enigma being decoded or figured out and cracked. We actually cracked the Japanese code too. I forgot how that was. That should have been a movie. And what the United States used for many of their communications was Navajo Indians. Yeah, and actually it created this movie, Wind Talkers. Anyone ever see that? Okay. But anyway, the reason that was so tough is Navajo Indians, their dialect was so unique. Like, let's think about Europe dialect. Most of it can be derived from Latin, right? So most of the languages are very close to each other. Even English and blah 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 blah. Navajo code was so unique that very tough to break. I don't know. I thought that was interesting. Then look at the next page. Does anyone know who that is? Does anyone know who that is? Come on, who do you think that is? That one guy that I watched 3 days of. You don't know his name? Alan Turing. That's the actual real Alan Turing. In this Algebra 2 book, they even give him creds for being cracking Enigma. That's why I love this. Okay, so now, love this book. All right, even though I stole it off the internet illegally. Decoding using matrices. Now it's the same thing. Look at this message. Of course it's nonsensical. Oh, and it's lengthy. I apologize. We'll try to speed this up. I should have left my answer from last hour. Okay, now in the directions on your test Friday, and in any other directions, like you'll figure it out pretty quick on today's homework. Where was the encoding matrix at? How were the letters put in the message matrix, we'll call it? And again, for this Algebra 2 book, the encoding matrix is on the right. The letters were put in order of rows, so they were put across. Okay, got it? Because then another stuff, I'm going to have letters put in columns. So the letters go in order this way. And then you have to know that that's how it's, you have to place them in there and then decode or encode, one or the other. So you got to read your directions. There's no fault other than your own for not reading the directions fully to know where does the matrix go, right or left, how do the letters go in. Okay, so this is the encoding matrix. So this is saying this has already been encoded. So there was a sensical message, this -4, 3. Before this, it was a message, all the numbers were between 1 and 26, and it was a message that made sense. Then it was multiplied by this matrix, and now it's nonsensical. So what do you do about it? You have to find the inverse of the encoding matrix to decode. So whatever you multiply by to encode, you multiply by the inverse of that to decode, and it'll come right back to where it was. And then you'll have a sensical message. So if you're playing this silly little game like the two boys in school when they were younger, they may or may not have been using matrices to do this, but you needed to know the secret matrix in order to decode the secret message. Just like in the Enigma machine, you needed to know the settings for the day based off of when they cracked it, what they knew what they said every morning, and said it over and over again. So this is why I don't think this is hard. How do I find the inverse of this A? 1 over what? What's it called? Starts with a D. D-E. D-E-T. I have no time for this. Determinant. Thank you. Okay, what's the determinant of this? What do I do with the 3 and the 1? Multiply them. Then what? Add or subtract? Subtract. Either know it or you don't. -2 times -1 is what? Isn't that the greatest scalar ever? What does that become? 1 over 1. What do you do with the 3 and the 1? Switch them. Why? There is no why. Just what? Nike. All right. And then what about the -2 and the -1? Why? Because. Stop it. Now, I'm going to recode the notes. Okay, I'm going to do it again because it's not that I don't like what this book does. You should do this way. Remember, I have to multiply on the rights of this. And I have to put these in order by the rows. This is a lot of stuff, right? So this is a what matrix? This is a what? 2 by 2. What do I have to multiply that by to even make this work if it's over on this side? A blank by 2. Now count the letters. 1, 2, 3, 4. Wait, 2, 4, 6, 8. Who do we appreciate? 10, 12, 14, 16, 18. So that'd be 9. 9 rows by 2 columns. Okay? So that's part of your job too. Not only finding out what side you have to multiply by on, how does that matrix line up? And then, see here it is. This is really large. I'd rather you put it in one big fat matrix, not a bunch of individual ones. And we're going to multiply that. I'll move in on this. Remember, the scalar multiple is 1, so 1 times this matrix is just that matrix, and I'm only going to write it once. 1, 2, 1, 3. Then I'm only going to do a couple of these. Go away. I don't know why this is things here. Why? Can you leave? Where does this go? How come this is? Thank you. All right. And then I'm only going to do a couple of these online. So, negative 4, 3, multiplied by 1, 2. Negative 4 plus 6. And I'll put this answer here. Actually, what I did in the other hour is I put the multipliers here, and then I put the answer above it. So it was negative 4 plus 6. And then I take this row, or the row times this column, and it's negative 4 plus 9, right? I'm not making any mistakes, am I? This row, negative 23 plus 24, right? Oh, I hate when that turns off. It gets so awkwardly silent in here. Negative 23 plus 36. Isn't it weird? Is this the one where the people dropped and it was a weird... No, that was third hour. Never mind. Who? Don't say his name. We're on the internet. He could sue me. Negative 26 plus 26. You are about to drop? Right? Negative 26 plus 13 times 3, 39. Of course I'm right. Sorry. All right? And so on. Okay, internet, you're probably about to die. Okay, see, here's the point. Why did the person that was encoding put a space at the end and end with a 0? It's because you needed the matrix multiplication to work. You needed a space. So when you're encoding, and say you had 7 letters only, you'd have to add an 8th letter maybe to make it work with multiplying by a 2 by 2. So that I just wanted to make a point of that. And then when you do this, I guess I'll color this in green. Is that green? No. This is 2. We all know what 2 is. That's easy. What's 2? What letter is that?
B.
B. What's 5? Keep going. E. What's 1? A. What's 13, I think? Okay, this is where it gets to be a pain. And I'll just tell you. Anyone know what 13 is? It's an M. Beam. Does anyone know what it says yet? This is 0. So that's a space. Then he just said it.
Oh, wait, really? That was it? What is it? I just kind of guessed.
You get the idea. Remember those two 20s? These are two T's. It's a Star Trek reference. If we kept going and kept translating the letters, it would say "Beam me up, Scotty." How exciting is that, isn't it? Okay, so I'm trying to get you to understand what happened to you yesterday. Silence. Okay, and I'm talking to the 84 family right now that has a particular button, and I'm going to ask you to check this first. But let's think about this. How do I solve this? Well, we learned yesterday that this is multiplication, and I can't divide. I have to multiply by what? The inverse. I didn't show you how to find the inverse of a 3 by 3 because it is long and maybe outside the scope of this class where we really just wanted to encrypt and decrypt, have a little fun with it. I don't know about fun, but, you know. All right, so let's do this for every day, Internet. This is what I have to deal with this new computer. It's very frustrating. Clear? Every day. Okay. First things first, 84 family. You with me? Eyes? Okay. Hit the alpha, and then hit the zoom button. And then rejoice if this just popped up for you. How many people did not have that pop up? Please, I cannot do the directions twice, although I am going to do it right now. Alpha zoom. Anyone not have this come up when they did this? Raise your hand, it's okay. Did not come up. Do you have the matrix, the rows? Do you not have it? Okay, but at least it shows rows and columns. Oh my gosh, this is I'm gonna cry. Oh, I gotta place it. So I have the arrow up there, hit enter. This is a 3 by 3 that I want. I guess I have to arrow over 3 by 3 and then press enter. Oh no, I have to hit OK. Oh my goodness, never was good at this. Okay, and then you get a matrix there. Now listen, before I continue, what did we have to do in order to solve for this? I'm trying to move the calculator. It won't let me. I can't. Why won't it move? Fine. I'll just get rid of you. All right. I have to take and multiply by the inverse of A both sides. Now you better understand this. I'm gritting my teeth on purpose. When I multiply by the inverse of A times A, what does this turn into? I don't have the time for this. It starts with an I. Identity. And what's identity times X? X. Whatever I do to one side, say it. Do the other. So all I have to do is multiply by the inverse of A times B, and I will get what X is. I'll have that answer. I should know that when I multiply inverse of A times A, I get identity, and I don't need to do that. I only showed you in your notes yesterday to prove a point. That was the only reason. Now we'll bring this calculator back up. And now what you have to go into there, son of a nutcracker. All right, hold on. Okay, I'm in. It's okay. 1, 2, 0. All right, 0, 0, arrow over, -2. This is thrilling YouTube video, by the way. -3. This random guy just putting numbers in. 3. -1. He's got some your management issues too. 5. All right, now 3. Now, what do I have to do to this matrix, though? I have to find the inverse. What's the inverse notation? What is it? Raised to the what? -1. Well, look at your button on the left side here. X to the negative first. That's all I have to do. Hit X to the negative first. Now that is going to find the inverse of that. And then you don't even have to hit times, but I am just for fun. Times. And then to get this answer, oh, come on, just move. I don't. Yay! Hallelujah! Which is just a random word of celebration, not tied to any particular religion. All right. Now I hit second zoom, and then this is a 3x1. So I have to go up and make this a 3x1. So again, those an Inspire, you do all the same thing. I'm not answering your question. I'm finishing the video. Oh, and then I have to hit OK. And then you'll see this come up. You're a lot faster than me. It's very hard to use this calculator on this. And then I type -1, -1, 12, and then -20. Okay, and then I hit enter. And lo and behold, I get an answer. And that is what X is. Because that's what is supposed to happen there. Now, I'm not going to cover the next one. I'll just kind of reference it, but we did have a question. We'll hit play, and then maybe it'll come back in. Okay, good. What? Okay, what is happening? Oh, my gosh. Okay, I did want to show this because I don't care. And I saw some people shake their heads like, yeah, I get it. All right, and then I'll talk about how this translates to what we could do. This one, in the other class, we actually solved this one. And I do want to cover it, but I'm not going to do it with the calculator. I'll do the other one. Okay, when I see X here, so here's X. What operation is being done right here? What is this operation? And then what's this operation? How do you undo addition? So wouldn't you agree I could name these matrices? Let's just name them. This is C, just for fun. This is A. This is, we'll just keep it X. And then this one's B. What I could do is say, all right, I could treat this as a real basic equation, subtract B from both sides, but I don't divide by A. How do you get rid of A? You multiply by the inverse on the left, and it matters. So it's got to be on the left. And then actually what I could do is exactly what I did on that last question, except I'd have to have inverse of a matrix times parentheses matrix minus matrix close parentheses, press enter. It'd be the same exact thing. Okay, it does take a little bit because it is kind of hard to press these buttons. And then I wanted to share this with other people, you guys as well, because I want you to remember when you had to solve a 3x3 system. And of course, last hour I was like, I don't remember that. I barely remember anything from Math 3. You did. And it's actually an algebraic nightmare. Okay, it is pretty tough. I shouldn't say that as a teacher, but it is tough for the students. We had to do some eliminating and getting the XYZ down to an XY equation, then solve that XY, then plug it back in. Does anyone have any recollection of doing that whatsoever? At least one student. That's all I'm looking for. 2, 3. Well, what you could do, and you actually can do this for a 2x2. I had this in your homework yesterday, but we just ran out of time. So I just want you to know that you could do it with this one as well. You could turn this into a matrix, so that's what I did first. Okay, fine. I'm just going to put matrix symbols around this, and matrix symbols. And then on the left, I'm going to pull out the coefficients by unmultiplying matrices. What? Well, let's just look at this as it is. Wouldn't you agree that if I took this row, and I'm just going to get rid of this after I write it, times this column, it'd be 1x plus 1y plus 1z. That's right here. So all I did is I pulled the coefficients out and made a coefficient matrix. Okay, now I'm going to get rid of that. I think that's the back button. Very nervous. Yay! Something worked. Then if I take the middle row times the xyz, you get 3x minus 3y plus 2z, blah, 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 blah. And then what do I want to do with this? I want to get rid of it. How do I get rid of this? There's only one way. Multiplying by the inverse. So if I call this A and this B and then this, x, y, z, whatever, all I have to do is multiply by the inverse of A. That gets rid of this, turns this into identity, which is this x, y, z, and then all I have to do is do inverse of A times B, and I've solved the system. Okay, so now, graphing calculators that are 83 and 83 pluses, and even if you could do it this other way, those that have 84s, you should do this. Here's the other way you can do this. Hit second matrix. I'll show you this again. Now, this is the 83 and the 83 pluses. You have to do this because you don't have the matrix menu. Okay, you don't have it. So you hit second matrix, which is above the x to the negative first. Are you with me, those that have an 83? Oh, we got it. Step one was missed. What time is it? Ah! Okay. Names, math, arrow over to edit. Arrow over to edit. Now, you have to hit enter, and we are going to enter into matrix A. We are going to enter into matrix A. We're going to do that. Enter. Now, what we got to do is create the dimensions, which this is a 3 by 3. And then you're doing the same. You're typing in the elements. So 1, I think it's arrow over. Maybe. Oh my gosh, I think I'm locked up. Maybe it is an arrow over. 1, enter, it's 1, enter. When I hit enter in the other way, it actually it shut down the matrix. It just evaluated. So you got to be careful. There's little conundrums in each little step that you have to do. 2, enter. 4, enter. 5, enter. Negative 10, enter. Now here's what's bad. And do hit enter and make sure you see that negative 10 click in. Here's what's good. This is matrix A and it's saved. So I can second quit and get out of there. And it's still in there. Now you have to go back in. This is a pain because I have to do matrix B. So hit second matrix. Let's try to move this calculator. And matrix B is kind of an annoying set of decimals, but that's fine. What I need to do is go over to edit. Stop. Go slowly. You don't want to edit A. You need A to be that 3 by 3. So we have to go down to matrix B and press, edit matrix B. Now, what are the dimensions of this? Otherwise, you'll get this screwed up. What are the dimensions of that? 3 by 1. 3 by 1. And then be very careful when typing this. 0.621. I guess it is enter. Negative 0.007. Just happens to be a little bit of... I'm just sharing this because I think, someone said they took the ACT last Saturday. And lo and behold, matrices were on there. Just a little addition. Just imagine if you went to college and you had to solve a system 3 by 3 if you had to take a college geometry class, which actually, that's sometimes the minimum. I'm giving you a little skill that matrices can help you with, but whatever. Now hit second quit. This is what's weird. Doing it this way, this is the only way. It's the only option. Now we go back into the matrix menu. We don't go to edit. Now we're going to start pulling the names out to the main calculator screen. And what I want to do is, this is why I wrote this over here. I want to take the inverse of A times B, and then what the result will be is what x, y, z equals. And you'll see this. It's going to be a 3 by 1 matrix that you get, and that's what x, y, z represents for the solution of the system. So here we go. Bloop, bloop, bloop. So I pull out A. What do I got to do to A, though? I got to what? I got to find the inverse of it, so I got to raise it to the what? Raise it to the negative first, and then multiply it by, go back into the matrix menu, and pull out matrix B. And there is inverse of A times B. Press enter, and you get 0.251, 0.3, and 0.07. That's what x, comma y, comma z would equal. All right, that's what x, y, z, because now I have x, y, z by itself, and it equals the other matrix that I just saw on my screen. So, with all that being said, in your homework, which I wish I could pull that up quickly, I don't know if I'll be able to find it. Don't do the first page unless you feel zealous, and you really want to get going. Is that the right word? I don't know. But you have to do page 3 on, because 2 is a blank. If you turn over the front page, the back page is blank. And I'd like you to do the first 4 without using matrices on your calculator. That means do it by hand. And then if you want to, try 5, 6, 7, 8 by typing the matrices in your calculator. Please pay attention to the order of where the decoding matrix belongs. You're decoding. So you have a bunch of secret encoded messages. 1, 2, 3, 4, 5, 6, 7, 8. You decode them all, and they all end up being 1 or 2 letter words, I believe. All right? And that's your homework. And you don't have to do the front page.